Hi, my name is David Elliott. I am the Super Guppy flight engineer for NASA Johnson Space Center. And you're looking at the Super Guppy. This is the last remaining flying Super Guppy in the world. It's one of 4 that was built between 1970 and 1983. This being the last one that was delivered to Airbus Industries in 1983. So NASA took possession of this in 1997 from Airbus to replace our aging original Super Guppy, which was built back in '65. So this will be a detailed walk around of the aircraft. I'm happy to point things out, ask any questions you got. So front of the aircraft, this big funny looking bulb at the front is our weather radar. Standard weather radar. Works like any others. We use it in flight all the time to avoid clouds. Funny thing about this aircraft is we don't like icing, so we tend to avoid icing at all costs, and that helps to keep it out of it. Antennas all over the aircraft, obviously. Pitot-static tubes on the sides. The Super Guppy, or the Superman logo, is nothing more than a play on the Super Guppy, obviously, but we like it. It's lasted for years, so we've kept it on there. Standard, nose wheel steering for this. There's only three systems on this airplane that are hydraulic at all, and one of them being the nose wheel steering, the other one being the brakes, and then our windshield wipers are actually hydraulic too, and we tend not to turn those on because they'll probably just squirt hydraulic fluid all over the window. So, but essentially this is where we would disconnect the nose gear. There's a big pin here. This is how we tow the aircraft. We'd pull this out, pull this down, and we'd hook a tow bar up here to pull the aircraft around. And we carry the tow bar with us everywhere we go because nobody has a tow bar that will fit this aircraft, so we carry it with us. Not much to show up in the nose wheel well, but you can come take a look at this gear. So our nose landing gear here, you can see it's a big DC motor, and so the interesting thing about this landing gear here, this nose wheel, is it's a 707 landing gear turned 180 degrees back. So this landing gear is going to fold this way. Now, as you know, most aircraft, you want the gear to come down forward so that you have the forward momentum to keep it locked in place, right, when you step on the brakes. This one comes up backwards. That's how they built it. So it is, but it's originally off the 707. So one thing that you'll learn about the Super Guppy aircraft is it's a Frankenstein. They've taken pieces off of a lot of different aircraft to make this thing work, and it works very well. But the nose pin, the nose gear pin, if you want to say, it's a big hunk of metal that you see gets stuck up there, and it basically prevents that thing from coming down. But that is all a heavy-duty DC motor. This is primarily a DC electrical plane. So, all right, let's see here. Antennas. We got a radar altimeter under there that we do call out radar. Like any large airplane that sits up high, landings are judging the distance between the flight station, the nose wheel, and the ground can be sort of difficult. So we do call out rad outs all the way down to the ground. The flight engineer actually does that for the pilots. This is the outrigger that we use on the ground to open the nose. It is just another big DC-driven motor, obviously big chain to drive this wheel. The only thing this does is provide the motive force to open the nose. It's not actually balanced on this at all. It balances on the nose wheel and the hinge, the one hinge that we have. So we use this to walk the nose open. Struts here that come down to hold the plane steady when we're loading or unloading, so that changes in, obviously if you're putting a bunch of weight on or taking a bunch of weight off, what's going to happen to those struts is they're going to extend or compress. And so these struts are put down to prevent that from happening and to keep the plane level the whole time. Let's see. Our static input for our instruments is all the way back here, so kind of far back from where everything else is, and we have to disconnect those when we open the nose as well. So let's see. This here is the intake to our air cycle machines, or ECS, environmental control systems. So I can show you the inside of those if you want to see them. I'll put this down here for now. I'm not tall enough. Actually, why don't you come on up here and I'll show you. So So we've got two ACMs, air cycle machines. These are a bootstrap turbine that basically takes hot air off the engines. It comes in through these orange wrapped lines, comes in directly from the engines, comes up through these, runs a turbine, a condenser turbine to cool down the air. It's got a water collection that sprays onto the radiator inside here. They work very well. So we've got two of them. This is a little squirrel cage fan for when your engines aren't running, you can get some circulation. So an interesting thing about the wings here. So the wings came off the C-97. The whole plane is built around the C-97 again, where they basically chopped it into sections, and much of the aircraft you can see is the same. But from this blister here, that's what we call it, that thicker part, from that outboard is all C-97 wings. I'll show you here, yeah. So from this part out, all that is C-97 wings. From this inboard is B-29. So they took a part of the B-29 wings in order to make room for the props. So with the fuselage coming out like that, the props would be impacted. So, yeah. So they had to add extra parts of the wing. So, you know, the history of this aircraft, they went from B-29, modified the B-29 for the C-97, modified the C-97 for the Guppy. So it's a Frankenstein, again. All right, let's see. So these engines, for those of us, so I'm a Navy guy. I did 20 years as a Navy P3. Very familiar with these nacelles. Anybody that's ever flown or really taken a look at a P3 will recognize them instantly. That's the same nacelle as a P3. And as a matter of fact, we got 8 brand new engines from the desert, courtesy of our friends at the Department of Defense. They gave us 8 new engines that we could use for our program, and those are straight off the P3. The blades themselves are C-130 blades. So C-130 blades have more low-speed torque, I guess is what it is. The P3 is more designed for a little bit faster speeds. C-130 is more for you know, carrying cargo and stuff. So these are actually C-130 blades. We got brand new ones of these recently as well, courtesy of the Marine Corps. So we try to repurpose, reuse a lot of things on this aircraft, you know, and it's worked very well for us. So the intake's on the bottom here, so that's your oil cooler intake. So this just has, it comes through here, there's a radiator right in here, and this is our oil cooler door. So this opens, we open and close this to meter the amount of airflow that's going through to keep the oil temperature at a regular operating temperature between about 50 and 85 degrees is where we typically, 60 and 85 degrees is where we typically want it in flight. So that's what we do. Let's see. So these are hydromechanical props. They adjust their pitch, so these things will change pitch in flight to maintain 100%. On the ground, we're adjusting the pitch of the prop with our power lever, but as soon as we push it up into the flight range, this will go onto a hydromechanical governor that will keep it on speed at 100%. So we give it more power, it'll give a bigger bite out of the air with these props and keep it at 100% but provide more torque. So that's what these do. It is anti-iced. All this spinner is anti-iced. We could turn that on to keep ice off the props. There's de-icing boots here on the black parts or to keep ice off the leading edges of the props. So, yep. And anyway, let's see. What else can I tell you about it? The upper intake there, so obviously that's the main intake for the engine. The engine comes down and flows through here and then out the exhaust. Standard turbine engine, suck, squeeze, bang, blow. It's all there in its glory. Let's take a look in here. Excuse the panels here that we got off for the ground operations. Okay, so if you want to look up this way. So here is our main landing gear. Motors. So again, heavy duty DC motors. They have a big power draw on them. We have 4 DC electric generators and we have 4 AC electric generators. So there's enough power on this plane to probably, you know, power the lights in a small town. But if you remember in the back, I told you about the clutch mechanism. Here's that clutch line right here. So when we pull that clutch, this cable will disconnect the clutch here. And that tube right there, that torque tube that connects right into here, that's where that crank would actually crank the gear. Need those? Go ahead, fellas. No problem. Hard at work, hard at work. So this is the landing gear actuator here, and you know, the motor drives it, and these gear do actually come forward. So again, the front one comes back, these ones come forward. You do have, you know, hydraulic brakes, so the hydraulics are coming in here and coming out to the brakes. So the way these brakes work, they're kind of interesting. They're basically big drum brakes. They have, there's an inboard and an outboard brake on each of these tires, and they have pucks, asbestos lined pucks that go all the way around, and then a inner tube that goes underneath those. So when we press the brakes, hydraulic fluid goes into this inner tube, and it presses all those pucks out against an outer drum to slow down the aircraft. So that's kind of interesting the way they work. Problem with that is nobody uses those kind of brakes anymore. The only people that use these are us and the C-97 that's flying now. Was it the Spirit of something? Anyway, that bird there uses them, and we talked to them about trying to find replacements. So the inner tubes, if you will, the hydraulic expansion rings that are in there, nobody makes those anymore. So we've got a big box of them. That's all there are. We're trying to find a vendor to actually replace those. We're looking at B-50. So these are B-52 tires. So we have actually done a study where we did a drop-in replacement for the B-52 wheels on this hub here, and they do fit. There's some modifications that have to be done, but we're looking into that as a possible replacement in the future too. We hope to fly this airplane. If we can't get a replacement for it, we'll be flying this airplane for the next 10 years. So that is probably our biggest thing, is finding those expansion rings and the different parts for the brake. So that's that. Let's see. We do have an anti-skid. So this center hub section here is an anti-skid, so it's measuring the, you know, how fast the wheel is turning, how fast the hub is turning. If there's any kind of slippage, it's gonna measure that, send it back, and it can release the brakes for you to prevent you know, lockup of the brakes. Standard anti-skid that works. So when you have the gear down, it's gonna release the brakes so you don't land with brakes on. What's that? Is that a jack pad? That's a jack pad, yep. Jack pad, low level fuel, that's a fuel sump there, so when they're checking their fuel, the quality of the fuel, make sure they don't have any water in it, they'll come out during the day and check that. Let's see, these are drain lines for the engine, so we got fuel and oil drain, so every time you shut down the engine, of course you have a little bit of fuel left over in the burner cans, and it'll drain out here. And oil as well from the nacelle. Let's see, what to tell you. So, in this bottom section, you can see this exhaust looking thing here. So originally on these aircraft, they had, the French called them a boulet. And a boulet is it's a big combustion section basically that would sit right up in here. And so they would light these boulets, jet fuel would come in here, they'd fire off this combustion section that sat right here to send hot air all along the wings for de-icing. So NASA, back in the early days when we got this, we pulled them out to do some planned maintenance, pulled them out, and they were all corroded. And we thought that was a fairly bad idea to be lighting, you know, a fire right underneath all this fuel. So we took them out. We don't use them anymore. The only section that is de-iced on the wing is inboard of those inboard engines. So that is just standard, you know, bleed air coming off the engines. We can de-ice the inside. We've had discussions about possibly sending, you know, hot air all the way to the tip of the wing for de-icing, but the fact of the matter is this airplane does not operate very well in icing, and we don't want to be anywhere near it. One of the interesting things is that whole dome there, the crown of the aircraft, will ice up as well. And so the fastest part of air, as you can imagine, air will actually hit this, and it can go supersonic over the top of that crown if you go faster than about 250 knots. So they've actually caved in. They did some testing probably back in the 70s, I guess, when they were testing these out, and they caved in the crown of this not this aircraft, but one of them. So yeah, we don't want to do that. So anyway, that doesn't get de-iced, so there's really no point in de-icing the rest of this. If we start getting icing, we turn around. Okay. The control surfaces are interesting because they're covered in cloth. This big old aircraft is still using this old technology for cloth covered surfaces. They work well. We don't have to do too many repairs on them or anything every once in a while, but generally speaking, they work fine. That's a landing light there. Yeah, just standard landing light. You can bring it down, bring it up. About 170 knots for those, I think. Yep. Okay, let's see. The flaps are up right now. Do you want to bring them down? Would you like to see them in the flaps? Let me see. Right. Okay. Yeah. There they go. Okay. So again, these are electric flaps. There's no hydraulics attached to these. You can see the big jack screws as they come down. There you go. So one of the things that we look for when we're up here in these flaps is all these flap rails that they're coming down here. They all ride on bearings. You can see those silver bearings there. These are big, heavy Fowler high lift type flaps. So up in here we have the big white line there is our refueling line, and above that is the cross ship. So that is for tank to tank or tank to other engines. We can send fuel from any of the tanks. So we've got essentially 4 plus the center tank, and each of those 4 tanks has several bladder style cells in it. And these lines allow you to take the fuel from each of those tanks. There's 2 electric boost pumps, a forward and aft pump in each of those 4 sections, plus the center. There's 2 in there, and you can transfer it from those to the other engines. Can't go tank to tank, but you can go tank to engine. So that's what all that is. Weight on wheel switches back here. So when the strut when we're on the ground, strut is compressed. This will do things like deactivate your landing gear, so you can't inadvertently bring your landing gear up until there's no weight on wheels. Things like that. There's a lot of switches that are associated with that. Let's see, this right here, so that's our debooster for the brakes, that white cylinder with the drop of hydraulic fluid on it. That's fairly normal, but that's the brake debooster. A lot of different hydraulic lines and fuel lines in here. Yeah, that's what we're looking at, making sure all the connections are good. And, if we were to have to do an emergency egress, we'd come out that side there, and if you look at it, it's pretty high up. This is where you put your foot in it. So you can just kind of sit on your butt, slide yourself out, put your foot here, and then slide down. Very simple to do. So, what else? Exhaust sections here, things that we're looking for on that. There's an aft oil scavenge pump that we look at. You're trying to make sure there's no oil coming out of there. We'll look at that all the time. The black piece hanging off there, that used to be part of an HF long wire. So they had HF antennas for flying over the ocean, right? You need HF radios. We took that out. We don't have HF radios on this plane anymore, so the wire is gone, but that's still there. All right, let's see. So this is the lower aft unpressurized section of the Super Guppy. We do have an access door that we can come in and out of. And we do keep some light cargo, like we have a couple ladders back here for the maintenance folks. We keep some parts in the back, but generally we keep it very low weight back here because it will sit. It's kind of sensitive to that on the tail, so we keep most of the weight up front. This right here is our refueling panel, so it actually just comes off. This comes off, and we take it out to the wing and plug it in. So it's not integral to the wing. We just have to plug it in the connector, and then we run off the switches from there. Bunch of chairs for air shows. Come on forward here. I'll show you a few things. Toolbox, and if you get your light up in here, I'll show you some of this stuff. All right. So what we've got here is the flat motor. And the flap drive, obviously coming through the wings here to drive the flaps up and down. This is an auxiliary motor for an emergency flap motor, and it also comes off, so we can actually take this off. It's got little connectors here, and we can pull the whole thing off, and we can plug it into these boxes. So these boxes are our landing gear manual extension. So there's a clutch that we use to disengage the the gearing, the drivetrain for the landing gear itself. We disengage it from the motors, and then if you look over here, you've got that big crank. So that crank will get plugged into that top notch here. I'm just turn this one. So we can take this off, plug it into here, disengage the clutch, and then we can crank the gear down. So bringing it down is pretty easy. We do about, I don't know, about 10 cranks or so, and get the aircraft out of the uplock, or the main landing gear out of the uplock. So once it kind of gets down a little bit, it'll just, gravity will swing it down. So as soon as we put the clutch back in, gravity will take it all the way down. And then once it gets down almost to the bottom, we'll pull the clutch again and crank it down until it gets into the down locks. So that's how we do the manual gear extension. Now this motor right here can actually be taken off, and you can plug that directly into here, and you can drive it with the motor. So if the landing gear was to get stuck and we weren't able to crank it down for some reason, or we needed to crank it up, if we had to crank it up, we'd probably use that motor, and it just has a 2-position switch for up and down, and you can plug it in there and drive it. Let's see, what else is in here? This is where they have refuel. This is a refuel valve here, so this is where the fuel comes into the plane. There's a valve here that they open when they're going to fuel. Lots of pulleys for flight controls and whatnot there. There's some feedback that goes from the flap. You can see this box here is basically feedback from the flap position. When you've got your flaps all the way down, it gives you a little bit extra loading on the elevator. And they definitely know it if that's not working right. That's pretty much what's back here.
Is that the wing spar? Is that fuel tank? Was that big?
This is the center fuel tank. So these are actually bladder cells in here, and these are big structural cross beams that go across here. These are the most beefy cross beams that we have. If you can see, all the rest of these are fairly, I don't want to say flimsy, but they're smaller than these big beefy ones here. We have actually done some pretty intensive stress testing on this and laser leveling on this. We had to do a lot of testing for that CSM that we moved, that I was telling you about earlier. For that 47,000 pound move, we had to do quite a bit of work on that, and they looked at how much these things deflect, and we've measured all that with lasers and whatnot. And we had instruments all over this thing looking at stress to the aircraft. So yeah, but these are the biggest ones. That's it. Here's our aft strut, stabilizing strut that again keeps the tail from sitting down when we're moving things around in the bay. These doors here are a positive and negative pressure exchange. So again, that is an unpressurized section of the aircraft, but if you didn't have those doors, flaps to allow the pressure to change as you change altitude, you would cause issues, right? So that's what that's for. Let's see, there's UHF antennas, again, cloth covered surfaces for the elevators, trim tabs on the inboard here. So we have manual trim that adjusts the entirety of the flight surface. Rudder trim, again, we've got some tail lights here that aren't on right now, but positional lights. That's about it. And as I said before, so that the leading edges of the vertical and horizontal stabilizer are anti-ice capable. We can send hot air out here to keep ice off of them. All right, so this is an interesting piece of history here I'll tell you about. So this portion of the aircraft, you can see where all the rivets are here, all these different rivets and all this whole area here. So this empennage area that connects your stabilizers and all that. When they were building number 4 here, the last Super Guppy to be made, they ran out of parts. So the C-97, I'm not sure if all of them have it, but a lot of them have a cargo door right here. And it actually, you can see the seam in the middle, but those doors would actually split open, and they had a winch that would be able to lift things up into the bay there. So they had to heavily modify this area. So this piece off this aircraft came, what they did when they couldn't find any parts, they went back to the original Pregnant Guppy, which had since been scrapped. So they went to the scrap yard where the Pregnant Guppy remains were, and they pulled this piece out of there to put on the very last Super Guppy that was ever made. The interesting part about that is that piece off the Pregnant Guppy, and now this one, came off the second ever prototype of the C-97. So that is the oldest, by far oldest piece on this airplane, and has been repurposed like 3 times. Left side, same as the right side. There's not much to show you. The big thing, I guess, is the hinge. Let's get a shot of that, because that's an interesting piece. So, as you notice, it's just one single hinge. It's a universal joint hinge, so it actually has some play to go up and down, twist a little bit. It's got a good bit of play in it, but it is a, you know, we've got it torque striped and everything. We keep very careful attention to that to make sure that we don't put too much stress on it, but that's the only hinge. So it rides, like I said, on that and that, and the nose gear.
Hi, welcome aboard the Super Guppy. My name is Brett Pugsley. I'm one of 5 NASA pilots who fly this aircraft. Before I show you the interior of the pilot and engineer station, I'll tell you a little bit about the history of this plane. It was developed to move the 3rd stage of the Saturn V rocket from the west coast to the east coast, which it used to be performed via barge through the Panama Canal, and we started using an airplane, and that shortened the timeline to build a rocket and to test it. There's many different variants after the first Guppy, but this one is considered the Super Guppy turbine. There were a total of 4 of these built. The first 2 were built in the early 70s with Aerospace Lines. When that company went defunct, Airbus bought those 2, brought them over to France, and they flew those aircraft around in their manufacturing process, moving different parts to different manufacturing sites. Later on in the early 80s, they found a need to build 2 more, so they got the plans, and they built Super Guppy number 3 and Super Guppy number 4 over in Europe. Once they were finished using the Super Guppy, because they moved on to their Beluga, NASA acquired this vehicle here in the late 90s, and this is Super Guppy number 4. This is the last of the Super Guppies that is flying today. Let me show you the plane around. Come on over here. What I first want to show you is where our engineer sits, if you want to pan over here and take a look at the console. So this whole cockpit is based onto that 1940s design of the KC-97, and instead of having computers run the generators and the engines, he's running that. He's got multiple different controls, whether it's all the different the engine controls that are right over here. He's got all the fuel controls. He's got a manually turn valves right here. These are all our electrical controls. We've got 4 DC generators, and we got 4 AC generators. He also controls the environmental control system along with our pressurization. If you look on over here, we've got the engine control area for the engineer. And this is a little bit different kind of a plane to fly, because we have the engineer run the throttles for us as the pilots. So we have our own throttles right up here, but generally as we're working, he's setting the throttles for us, and he has the only capability here to shut down our engines. So this is up front and close into the pilot station. We've got the first pilot will be sitting into the left seat. The co-pilot will be sitting into the right seat. So looking at the aircraft controls here, you got your 2 yokes. This plane does have hydraulics, but the hydraulics are not for the flight controls. It's all by mechanical advantage and by push rods, cables, and pulleys. So sometimes it does take a little bit of force to get her going. For handling on the ground, we've got a tiller wheel here, and it will steer our nose wheel steering. And then our nozzle steering is actually run by hydraulic power as well. Could just show you the different controls we have here. Still fairly antiquated. We did make some upgrades to the cockpit here. You've got your standard turn needle ball. This is our airspeed indicator. It's a little bit different. We've got a bezel that rolls around right here and it will tell us our indicated airspeed, also along with a needle that will show you your airspeed. It's got your standard primary attitude. And below that is, it's not on right now, but it's our, basically it's an HSI, horizontal situation indicator, and it'll give us whether we're on course or high or low on glide slope. Got our altimeter, fairly standard right there. We did introduce a digital vertical speed indicator, and this one is instantaneous. On the other side, on the co-pilot side, you'll see here it's kind of disguised behind the control column right here, but it's a old school pitot-static VSI system. We do have a radar altimeter, standby gyro, and then we have a multifunctional display which will show our weather radar that we did install. It's an upgrade on this aircraft, and also the our nav route, our GPS points where we're flying. Now, unlike the engineer display, we only have, for each engine, we only have 3 different gauges. We have a temp gauge, a torque gauge, and an RPM gauge. And as you saw before back on the engineer station, they have a heck of a lot more gauges telling you what's going on with each engine. So very limiting from the pilot perspective. Like I said before, we're calling out different torque settings, and the engineer will set that for us while we're flying. All the way down to touchdown. We're telling them all individual torque settings, all the way down until we just about to touch down, and we'll tell him to walk it back. He brings the throttles back to idle. We'll touch down. Co-pilot will then lift up the throttles, and they'll pull them back into beta, telling the pilot that he's got 4 good betas, and these are the 4 beta lights. It means we've got good reverse, and then the pilot flying will pull the throttles back and pull it further into reverse to help us slow ourselves down. You got your typical, you got indications of the landing gear is down, but we also have pins that are engaged in both the left and right hand side. Make sure that the landing gear is down and locked. And we do have some other indicators of different issues that you might have while you're flying here. This is our flap position indicator, free air temperature, and the rest of the indications or the displays on the co-pilot side are the same as the pilot side. This right here is our control lock. So right now, because this is up and engaged, this is just locks our flight controls in place so they don't get blown around with the wind. We've got our landing gear handle. Right now, of course, it's in the down condition. We manually put out our lights. We've got to extend or retract our lights. They come, they lower out of the wing, and then we can turn our lights off and on right here. This is our flap switch, and it just, we don't put a, we don't set it to 15 or 30. We manually move it up and down, and then watch the gauge over here and make sure it's in the right position. If this switch is not working, we do have an auxiliary emergency flap switch right here that we can manually raise and lower the flaps with. We have a throttle gate that we will, once we get ourselves up and away and flying, we'll engage this. So basically it enables us to have a higher flight idle, so we can't get too far back and stops us from having too little power while we're flying. But as soon as we do touch down, the co-pilot will pull this back before he gets the throttles back to idle and into the reverse. We normally, when we start an aircraft, we're going to be in a low RPM state. They'll be just above 70% RPM. And once we get the engines either warmed up or we got ground crew personnel away, we'll turn all our idle or RPM switches up to normal, which will get us up to here. Now we'll be running at around 100% on our engines. Additionally, we also have you know, 2 different hydraulic pumps right here. You've got your service hydraulics, and you got your main hydraulics, and then you've got your emergency hydraulics, which is over here. The co-pilot handles, you can see that right there, and you can charge it, discharge it, and if you turn all the way to the right, you'll see our hydraulic indicator. Turn all the way to the right. See that little tube sitting up there? It's old school, but there's a little tube right there, and that shows us that we got good hydraulic quantity, and that's the reservoir back there. Different avionics are back here between the 2 pilots. We've got our IFF, and we do have TA, but we do not have RA. This is for the co-pilot side. This is just adjusting the HSI display, changes the different nav modes, the ranges, and whether you want to be in an HSI, so full 360 degrees, or be in ARC mode. We have 2 sets of VHF radios. Here's our COM2. We got COM1 over here. And then we have 2 different VHF navigation radios right here. This is our number 2, and this is our number 1 nav radio. Standard mixer switches here for selecting different radios. And then just some audio panels here for talking, whether we're inside the aircraft or talking out to ATC with our microphones. Got our rudder trim here. Elevator trim right here, aileron trim right here. Interesting enough down here, I don't know if you can get the camera over here, but the rudder pedal adjustment on a lot of aircraft, when you adjust your rudder pedals, you're going to just either have a crank switch or a lever to adjust them. In this one we have a little toe kick out, so we push this and this adjusts the rudder pedal. So interesting enough, you can get them kind of out of sync, so it's kind of tricky on pre-flight to get them perfectly straight in the middle for flight there. And up ahead here we can basically we can feather our props if we need to in case an emergency. And also we have an auto feather switch which we have turned on for all takeoffs. We have 2 different inertial navigation systems right here. And then we just have individual light switches right here. Pitot heat. Over here, overhead the pilot position, you do have our emergency brakes right here, and they're individual left and right handle right here. Parking brake switch is right over here. We do have we have 1 fire light here, so if this is illuminated, we actually have to turn around and look back over here to see what engine. These things will light up whether there's a fire in which engine. This is a very crew resource intensive aircraft to fly. In a lot of aircraft nowadays, you just have 2 pilots flying. Well, now we throw in an engineer, and if we're on missions, we'll have 2 engineers flying with us, okay? And so every time we're flying, we're all 3 of us working together versus having 2 people. So it's pretty CRM intensive to us all to work together as a team. So for initial takeoff, we'll get ourselves lined up on the runway. We'll call set takeoff power. Pilot, say if I'm sitting in the left seat here, I won't set this takeoff power. I'll have the engineer in the back. I say set takeoff power. He'll run the throttles up and we'll set the takeoff power, make sure it's in the predicted torque settings before we release the brakes, and go ahead and go flying. The pilot non-flying, he'll hold the yoke, and if there's a little bit of crosswind, as you can tell by the shape of this this aircraft, it's affected greatly by crosswind. So if there's any bit of crosswind, he'll have some sort of yoke input, whether it's left or right, into the wind to make sure we keep a level wings as we're going down the runway. So when we're flying, I'll have my hand on the tiller, I'll have my hands on the throttles as we're going down the runway, and from there it's just using nose wheel steering. through the tiller till we get about 40 to 50 knots. Once I get 40 to 50 knots, I'll still keep my hand on the tiller in case we need to slow down, but most of my lineup controls are going to be with the rudders as we're trekking down the runway. This is an interesting plane because it's a lot of the inputs when you put them in, it's delayed. So I'll put a little bit of right rudder in there, and you just have to know that that's the appropriate amount of right rudder, because in about a second or so you'll finally get that that control input will be giving you directional, like we'll start giving you a little bit of a turn at that point. So if it's an out of the loop kind of flying, and if you are too in the loop while you're flying, you'll end up getting into some pilot-induced oscillations on the runway. So you have to be kind of gentle as you're going down the runway. Once we get ourselves to 80 knots, the co-pilot will call your yoke. I'll get my hand off the tiller and I'll take the yoke from there, and we're trekking down the runway. Once we get down to V1, hands will come off the throttles there, and then VR will rotate. Generally, a lot of times, V1 and VR, they are pretty close to the same number. And then it's off from there. Like I said, the flying controls, once you're up and you're airborne, you know, it takes a little while. Like I said, you got to be out of the loop. You put in a turn input and it'll slowly start going. Sometimes if you're a little bit slower, she'll turn a little bit to the left before she starts turning right. But I'll tell you, this is the most challenging plane I've ever flown in the landing environment. The max crosswind for this plane is 20 knots, and that's quite a challenge there. When you're coming in on lineup, we fly wing down top rudder as we're coming in to be lined up on the runway. And we're pretty much at 20 knots. If we're right there at our limit, you got a full boot of right or left rudder and an opposite aileron to keep yourself good alignment with the runway. And you'll land on that left or right wheel, and then you'll come down and you'll get the nose, and then you'll get the other wheel back down, and we'll get ourselves into the reverse. And that's pretty challenging in gusty wind situations because of how she responds to your inputs as a pilot. Gear speeds, you can first let's just talk about the airspeed of the plane. So max airspeed, you can take a look over here. We've got the barber pole right there. It's 210 knots till around 14,000 feet. Then we start getting into Mach effect. Once you start getting into you know, the highest indicated Mach, this number is going to start coming down on you. And that's right here. If you take a look here, here's your air speeds here. Our max operating 210 at 15,000 feet, and then as you see, your indicated airspeed starts coming down. All the way up, our max ceiling is 25,000 feet. We've got our turbulence airspeeds, they're right here. So this is our depending on our gross weight, the higher gross weight, the higher our turbulence airspeed is. For operating the landing gear is 201 knots. Flaps 210 for going to flaps 15, flaps 38 for landing. Max speed is 174. And this speed right here, 173, that's the landing light extension. So talk about this plane a little bit more. Our max aircraft weight for takeoff is 170,000 pounds. Our max for landing is 160,000 pounds. Dry weight, you're looking at about 104, 105,000 pounds. And so we can get some pretty heavy loads on there, up to about 50,000 pounds. We're flying a 50,000 pound load. Depending on the altitude of the airport and also the temperature outside, we may have to use something called water meth. I don't know if you've heard of water meth before, but it's a 50-50 water methanol mix that we have certain tanks that are right next to the propellers. We'll turn on water meth, and that's right here if you look at this gauge. So for some certain takeoffs, we'll turn this on. It'll give us more torque for takeoff. So we have the actual performance to get ourselves airborne. Sometimes we need that water meth on for actually our go-arounds if we're flying and it's unsafe to land, or the airport tells us the airport's not clear. If we're too heavy, we'll have to make sure the water meth is on, and we'll use our water meth to give us the performance to go around. Bank angles. We're limited to 30 degrees angle of bank until we get to a certain vertical CG. If we have a cargo back there that's got a higher center of gravity, brings the total aircraft center of gravity above a certain value, then we're limited to only 20 degrees angular bank.
Okay, so we're going to prep the aircraft for opening today, and the first thing that we're going to need to do is to start taking some panels off. We have to turn the nose so we can open it, and you know, these fine gentlemen here, our ground crew, done numerous ones of these, so I'm going to get these guys rolling on that, and you can follow me around and watch the action. Okay guys, if you want to go ahead and pull the panels, okay. And is Nelson upstairs to turn the nose? Yeah, okay, we'll go around front here and let's get this nose turned. Tommy, you want to watch that for me? Ready? All right. So the interesting thing about the way that this airplane opens, it's basically balanced on this one hinge at the top and then the nose gear. So what we're going to do now is turn the nose gear about 60 degrees here, and it'll drive on that when we open it. So. Okay, so you can see here the fellows have got the panels off now, and what you're seeing here, this is called the outrigger. So this is going to be the motive force to actually move the nose open, and this is right here is one of our stabilizers. So the next step of this evolution is going to be to bring the stabilizers down so that the aircraft doesn't move while we're opening the nose. So. Some other factors that we considered when we're doing this, we're always looking at the wind and the weight of the fuel, or the weight of the aircraft itself. So we have a minimum of 12,000 pounds of gas that we want on this aircraft. Really, we always try to put at least 16, but anything less than that, when we take weight off the aircraft, the struts will extend and it gets really, really difficult to get back together. So we check that weight, put fuel on if we need. So usually the first thing that we do when we land is put more gas on, so we've got enough weight to keep the struts settled. And then we check the wind. So the wind has to be coming from the left wing, coming straight over the left wing. The more, the closer to that, the better. It could be anywhere in that vector. But essentially, once this nose gets opened up, it's like a big Dixie cup. If the wind's coming from the right side, it can and has pulled the nose right off. So it hasn't done that with us, but Airbus over in France had an incident where the wind shifted 180 degrees, and they had like some kind of microburst or something, and it pulled the nose right off. So, all right, this is my other flight engineer, Nelson Reyes, and he's going to be running the checklist today so that I can talk you through it. Nelson, go ahead. Do your magic there, and we'll start pointing out what these guys are doing. So you've got them putting blocks in now. Yep. Come on up here, and I'm going to show you what the fellas are doing. Okay. So in this area of the aircraft, this is primarily where we do our work for opening the nose. This is Tommy, Dave, and Fernie. Been with the aircraft for several years. The first thing that we have to do is put some blocks in place. So if you see these silver blocks here, they've been slid into these gates and pinned. There's going to be another one. You want to show them how that works, Fernie? Yeah. So this block here, and it's going to come right up here, so you may want to yeah. There you go. So there's 8 of these blocks, 4 on each side for the flight controls. And if you want to come step over here, probably this is a good spot, and we'll let these guys show you how they do this. So once these blocks are in place, it holds the flight cables on either end, so we don't have to re-rig when we disconnect them. These are all quick disconnects. So all the flight controls are fly-by cable. There's no hydraulic assist. There's no electric auto trim or anything like that. These are all just cables and pulleys. So they're going to disconnect all of these in the middle once these blocks are in place, and I'm going to let Nelson get up here and verify everything before we do that. This is a critical element of this evolution. Obviously, if one of these is not in place and we jump ahead and disconnect these, we have to re-rig the whole flight control. So we're very careful about timing on this. So let me get Nelson. Nelson, you want to go ahead and verify them before they start disconnecting cables?
It's a great system. I mean, because of the system, we don't have to rig the flight controls every time we open a nose.
Yeah.
I mean, you can imagine hours spent rigging the flight controls after every nose, and after every nose open and close, it would take all day. Okay, I've got one more set right here, you guys.
Yeah, I was just going to
Get out of your way.
Okay, disconnect still all control cables. Disconnect power cables, connect extension cable. Disconnect electrical connectors, 2 each above crew entrance door. Disconnect ECS ducting.
Done.
Remove outrigger and jack fairings.
Done.
Close hydraulic pump life station valve.
Done.
Disconnect and secure hydraulic lines.
Hydraulic lines, done, sir.
right there. They're already hanging.
Okay. Okay, I'll go to the aft.
What's up on? This one goes in the bottom right.
Tailoring light out.
All right. Can we bring those up a little higher, Tommy? These cables up here need to go up a little higher. If you put a little more tension on that set of cables, and I'll be back. Okay, you want to do this?
Yes, sir.
Okay, remove upper jack pin.
This one right here.
Yep. Okay, extend jack with winch. So we're going to lift this up 6 inches off the ground, put a pin in, and then we're going to lower this aft stabilizer hydraulically just to put some pressure on the tail to support the aircraft when we open the nose. Okay, coming down.
360.
Here we go. Clear?
Clear.
Okay, here we go. Okay, let's do the jack. Disconnect outrigger cable, remove upper jack pin.
He was testing you, Fernie.
Good job, Fernie. Yep.
Coach it.
Oh, one more.
He's got you one more turn.
Yeah. Hold on.
Still gotta do this.
Oh,
Okay, Bernie. Pretty equalized. Thank you. Okay, nut, 1/4 inch. It.
Okay.
Okay, install outrigger control handle and steering bar.
okay.
Okay, ready for auto locking locks?
Sure.
Oh, this is so cool. Oh my gosh.
good.
There you go. All right. Sit here so you can see. Cracking over there. Yeah. Let you guys get down first. Yeah. All right.
Okay, we're checking all manual and aligning pins. So we have another set of pins that will come out. These are manual pins. And they're between each auto locking pin.
Watch over there. Look at that one right there. You should be able to see it coming out. That one right there. Yeah, see? Oh, that's the.
Yeah, yeah.
That's right. You'll just actually.
And then
Get a good shot. Oh yeah, yeah. Starts pulling out.
aligning pins coming out. Okay. Dave is doing another final check to make sure that everything is disconnected and where it needs to be.
That's good.
See?
All good?
they're doing right now is they're measuring. This is the center line to the aircraft, and then this one will be measured off so that the other left side wheel can track down that. It just helps them line it up, because of course when we're pulling things in and out of the aircraft, we're dealing with the rails on the aircraft and also the rails on the loader, and it's very tight tolerances. We basically have about a ½ an inch on either side. So yeah, so these guys have to, this particular loader isn't motorized itself. We have to push it into position, and so there's not a lot of fine tuning, so they kind of got to have a good long run in for it to work real well. We've got another loader that is self-propelled and can move a little bit easier, and then we also use like Air Force 60Ks as well. So we have to have a loader on each end when we do these missions, so we'll have one for loading the payload and one for offloading the payload, and they go, you know, typically by truck. So it's ironic that we're, you know, flying these huge payloads in the plane, but we also have to truck the support equipment to even do it. So it's not as easy as just showing up somewhere like you know, like a C-130 or a C-17, where you can just drop the back and roll things out. It's a lot more self-sufficient, those aircraft are, than this one. But this has a 25-foot diameter, so we can fly things that none of them can. It's the largest diameter, interior diameter of any aircraft in the world, including the Beluga, the Antonov, any of those. So it's bigger than that. Unfortunately, it doesn't carry nearly the weight. So a maximum payload on this airplane is about, well, the largest thing we ever flew, which was the Artemis spacecraft. It was it's called the Crew and Service Module, CSM. So for Artemis 1, the one that just went around the moon, we flew that in this aircraft from Florida to Mansfield, Ohio. And that was about 47,000 pounds. That's the largest thing we've ever carried. And it took us 2 fuel stops on the way up to do it. We basically were flying about an hour and 15 minutes between fuel stops, just to kind of leapfrog over the country to get it where it needed to go. Early 60s space race. You know, we're trying to beat the Russians to space. We're trying to beat the Russians to the moon. All those different things are going on. Politics being what they were. There's a lot of money being pumped into the program. One of the big time critical elements was getting the Saturn boosters from the West Coast to Cape Canaveral, where they were going to be launched. And what they were doing is putting them on a barge, sending them south through the Panama Canal and then back up to Florida. That was taking about 2 to 3 weeks, depending on weather. And of course, you know, any kind of weather, you know, along that route would put a stop to things and cause delays. So there was a man out in California. He was an aviation entrepreneur. That he had a friend that had bought a bunch of excess Air Force C-97s when they retired them, and he had, I want to say, something like 17 C-97s out in the Mojave Desert, and they were just sitting there. And so so the man that built, that designed and built this, his name was Jack Conroy, and he basically, you know, it's one of those tales where they were sitting around a bar, had a napkin, and were mapping out, you know, I think we can do this better. There's a need, the country has a need for this capability for an oversized airlift. And so they thought up a way to use these C-97s, modify them for what they are. And so that was early 60s, 1963. They flew for the first time the Pregnant Guppy. So it was called the Pregnant Guppy because somebody looked at it and said, wow, it looks like a pregnant guppy, and that's how it got its name. And that name has pretty much haunted us or stuck with us you know, ever since. But the original Pregnant Guppy, it had, you know, the way that it opened was it actually pulled the whole tail section off the back. And it was very time consuming. They had a trailer that would go underneath where you see the strut. They actually had a trailer that the tail would rest on, and they had to drag the whole tail off, and it took several hours to do it. And getting it realigned again to come together was very, very difficult. They did fly it. They did like a proof of concept, flew it to Houston. Wernher von Braun actually flew on the airplane and said, yeah, we need this. This is the capability that NASA needs. And so we hired them. And so they put a dummy dummy load, fake Saturn booster into the plane, flew it from the west coast to the east coast. It made it, in a couple days, and they said, okay, that's well, we want that. So they started flying Saturn boosters. Well, at some point, there was a malfunction in one of the engines. So they actually broke down in, I believe, Dallas, somewhere in between, and the plane was there for about 2 weeks while they changed an engine. And so it put a delay to the whole program, so NASA said, hey, we want another one. So they went back to the drawing board and they built 940, NASA 940, which is out in Pima at the museum there. And that one was the first turboprop. So Super Guppy, they called it the Super Guppy, had turbine engines on it, 3-bladed props, electrical props. It had a carriage that you actually had to pull out of the airplane, put underneath the aircraft to move it back and forth. They had to physically lift it out of the airplane to do that. And they had the scaffolding up above there to take the locks off. That one flew until, I want to say, 93 or so. NASA took possession of that airplane in the late 80s when the company shut down. ATI, Aerospace Lines Industries, shut down, and we took possession of it and flew that until like 93. Meanwhile, Airbus overseas, they're building up their Airbus 300 fleet, and they saw the capability of the Super Guppy and commissioned ATI to build 4 of these airplanes. And so this one is number 4, the 4th one ever built. But they are built, all the aircraft are built off those same C-97s that were out in the Mojave Desert. This particular one came from a C-97 that was built in 1953. So the hull of the aircraft is decades old, from 1953, and they first flew it as the Super Guppy in 1983. Okay. So this is where we operate the winch normally for ground operations. When we're doing any of our cargo loading, we have a pendant here, and there's actually a similar one at the back for larger loads. And we plug it in, and it's just got a dead man switch, emergency stop, forward and reverse. So this is how we operate the winch that's down below. I'll give you a good shot of that later. The locks that you see here, these are all hydraulic locks that we put in place to hold our pallets, and they lock into position. They're controlled by a panel up front that you'll also get to see in a minute. But essentially we're going to move the loader into position, lift it up. Once it gets to the right level, we'll start to roll this. We'll unlock the locks, roll this into position, and they'll lock it into place on the loader. At the back of this pallet, there's a winch bar that we attach that we'll have to disconnect before we can pull it off. And that's how we pretty much do the same thing every time. We put people on both sides to make sure that we're gonna clear the edges that we need to, and pretty standard stuff. It's not too bad. So this piece of equipment here, we call this the Mighty Grip. And it is a engineering marvel, basically, that they used. They designed this a few years back. We had a large, very heavy piece of metal that would lift all of our wider payloads. If you notice, of course, the widest cross section is about, I don't know, maybe 10 feet up. So this is designed to lift those wider payloads up into that section. So before we built this, we had a very heavy piece of metal. This reduced the weight about half. So it works really well, and it's very modular. We can take off sections, we can move them forward or back. It works really well. So this bottom piece here is called the grip, this is the Mighty Grip here, and this is the Mini Grip that goes on top of it. Engineers have their acronyms, so that's what it is. But we carry a Loadmaster with us. The Loadmaster pretty much handles all the chains for us. They handle the weight and balance numbers, so they know where to put this, slide this into position. These are every, 2-3 feet, I guess, and the pins are every 6 inches, I believe. So they can get very exact on where they put the weight in this aircraft. The interesting part about the center of gravity, though, is not only do we have to deal with just the normal center of gravity, we also have to deal with vertical. So we use they judge it by water line is how they call it, and once we get up to a certain point, the aircraft is limited to 20 degrees angle of bank. Because it's so heavy, like we get that weight way up above the wings like that, and as you kind of roll, it'll be very difficult to get it back up. So we just limit our angle of bank to 20 degrees when we're above, was it 152 on the water line. So
If you're empty, what's your limit?
well, we won't go past 30. It's not a comfortable feeling when you get too far into an angle of bank. It is a very sluggish airplane to fly. So because it's all cable and pulleys operated, and because it's so big and unwieldy, there tends to be an input delay. So you roll the aircraft and it'll slowly start to roll, and when you roll it out, it'll slowly start to roll back. So yeah, we watch the water line, the vertical CG in this aircraft quite a bit. Interesting piece of history. Back when they were testing what that limitation was on the aircraft, they tried to fly the airplane with a very low fuel quantity in the engines and a very high vertical CG, and they did some test flights out of it, and they got into a situation where I guess they had too big of an angle of bank and there was too little fuel in there, and it actually starved two of the engines out at one time, and they ended up in a two-engine situation in flight. And thankfully we're able to properly shut them down and restart them and land safely, but it was an eye-opener as to the amount of fuel that could be safely flown. There are electric fuel boost pumps in the tanks, but there's no hopper. So if you're familiar with aviation at all, you know that in each of these fuel cells, typical modern airplanes have what's called a hopper. So they've got one-way valves that the fuel will come in and basically get stuck in a low point. We don't have those in these. They're all bladder cells, and so that caused a dangerous situation at that time. So this particular loader, it's called a Cargo Lift Trailer, and has been in operation since the Apollo era. It is very old. There's some historic photographs out there where the original Super Guppy and Pregnant Guppy even were using this same loader to move like the Apollo capsule and all. So. this winch cable is a continuous loop, so it pushes and pulls the payload in, and that's just the cable running there. I can show you the winch itself down below, and this is just a winch bar that we use. It has actually kind of I don't want to say triangle, but it is definitely a weaker point at the front so that if it gets stuck in the bottom, standard winch. That's it. We are done here for today, so we'll get the SGSF in on Monday. To give you a brief look at the cargo bay without anything in it, some of the things that we're looking at back here, we do have emergency exits on either side. Pin pulls out. You actually, if I can show you how this works here, you just drop this out and then you pull the whole thing in. So if we had to do an emergency egress for some reason, that's what we would do. It's quite a drop, so part of our emergency procedures, if we had an egress on the ground, is to drop the flaps all the way down, and you can essentially just sit on your butt and slide off the side, and there's a foothold that you can put your foot in and just kind of work your way down. It looks a lot farther than it is, so it's not too bad. But we have a rope that we actually will throw out there so people have a handhold. I find we don't really need it, but there is one. We have life rafts. We don't take this aircraft over water very, very seldom, but we do carry them in case we go out over the Gulf or something like that. This is in the continental United States only, in CONUS only, so we do get inquiries every once in a while. We get requests to go to various places around the world to pick things up, and we've done the math on it, and there's just not a lot of wiggle room for fuel, so we have not done anything like that to this point. The last time that this thing went over the open ocean was when we got it from France back in '97. So they flew it completely empty except for gas and a few people, so that was it. Back here, I'll show you some things. These items here, the light bulb looking things below the actual light, those are actually, they read smoke, so it's a light. Basically, it's looking at the light in between those bulbs, I guess, and it gives you a smoke detector. That's how it works. They're iffy. We test them. They work, supposedly. We've never had any smoke in the back here, so I can't tell you whether they would detect it, but they look like 1950s technology, so there's probably better options. This line here is actually for our tail de-ice, so we use hot engine bleed air like most large aircraft. We take hot engine bleed air and pipe it back to the horizontal and vertical stabilizer to melt the ice off the leading edges, and that's what that comes from. This right here, so we call this the chapel, and you can kind of see why. There's not much back here. We have our emergency locating device and the cockpit voice recording, so we do have those on this airplane. And that's where it is. And then if you want to, you can step back there and kind of get a view around all that. You'll see the pulleys and all for the rudder and all back there. So not much back here, but it's kind of an interesting. Everybody always wants to know what's behind the curtain. Now you've seen it. So we do have there's two access doors to the lower section, so this is all unpressurized in flight. We don't normally come back here. Right after takeoff, we'll keep it depressurized, and the load masters will come back here, check all their chains, make sure nothing's shifted, and then as soon as they're done, they'll come up front, we'll shut the door, and we'll pressurize the flight station again. So when we're closing the nose, one thing we're looking for is all those locks. You can see all the holes where the locks, the auto locks around the top, the manual locks, we have to make sure all those are flush. So they do leak sometimes and they'll start to pop out. So one of the first things we do is make sure all the locks are put back in. Then we're going to drive this nose close just the opposite way we drove it open. And I'm not sure how much he told you about it, but in general, this outrigger that we're driving here, the only thing it's doing is providing the motive force. This bar right here, all this is doing, we're just looking at the gap between the outrigger strut and this guide bar. So as we're turning it, if he turns it out, the gap is going to get wider because we're putting stress on this bar. It's actually going to start to turn in, and we're tracking on that nose gear. This is not actually turning anything. All we're doing when we turn this bar is we're just keeping this bar straight up and down. That's all we want to do. And so this guide bar here, all that's doing is giving us a visual reference to see if we need to bring it in or out, so that we're not putting too much stress on that. That's all we're going to do. So Nelson's going to drive it back in. You got it. You got on this one, I don't know how much he showed you, got a dead band switch again to turn power on, and then you've just got, you know, in or out, forward or back. That's it. So take it away, Nelson.
Okay.
The other thing I will add, we'll talk about as we're going, you notice the yellow hold bar that's in the nose wheel well there. That is put in after it's open. Now we may have some issue if you notice there's a bit of a dip right here, so hoping it's going to go over. All right. Look. This way. Okay, so one of the hardest things about getting this back together is anytime you take off any amount of weight on this aircraft, it's going to rebalance all those support struts. So what we've got to do now is essentially we're going to raise up both parts of this, and we're going to try to create a bigger gap at the top. So you can see it's kind of an inverted V right now. It's a little bit smaller at the top than it is at the bottom. So it's putting a lot of stress on that, the hinge on the other side. So what we're going to do is we're going to raise this side up, and then we're going to raise this side up, and it'll kind of create another V, and then we can hopefully get it back in. So. So what we'll do is we're watching these circles here. Where are they? Right there. We're going to watch these circles. We're going to bring them up about a full circle length. And Nelson, just tell me when. Okay. And then we're going to raise up the outrigger to match.
That's good. So we'll need a
Okay.
turret or two.
Yeah. So yeah, bring it out and then tighten up the bar. So the other way that we can make small adjustments is we can actually tighten that bar up. So what that will do is actually turn that wheel ever so slightly. So we can either loosen it up and the wheel will turn out, or we can tighten it up. Most of the time we're having to tighten it up to bring it in closer. So just got to back it up, tighten that bar, and bring it back in. Yeah, give it a few turns there, Tommy. Yeah, that one. Right. No, going out?
The other way.
Yeah, there you go. Keep going. So you can barely see it, but the tire is the wheel is actually turning in just a little bit, so that's going to drive it further into the to the center of the aircraft. So. Okay, now we're going to go again. Good. Good. Pretty darn close. All right, so I'm going to raise this up a bit.
Very nice.
Right there.
Very nice.
Okay. And now, if you want to see this, Eric. All right, so the first thing we're going to do is we're going to go to extend, open this valve, and we're going to go ahead and put the alignment pins in. So that's that big sharp one that you were taking a picture of early. So that's coming in to pull everything together nicely. And so what I'm doing is I'm watching this pressure gauge to see when it builds up pressure, up to cracking pressure. And here we go. So our alignment pins are out. Turn that off, close the valve. Now we're going to extend our manual locking pins. And again, I'm watching my gauge here. And as those 6 manual locking pins come out, get the cracking pressure, close our valves, and we're good. So, ready for the nuts, fellas?
Yeah.
You got them. Manual locking nuts, please. Good morning, everyone. Welcome to day 2 on the Super Guppy. So as I was saying yesterday, the Guppy is very susceptible to winds, and unfortunately looks like they've shifted on us. So we're going to have to turn this plane 180 degrees out so that we can load this today. This is the Super Guppy shipping fixture. This fixture has been around since the beginning of the Space Shuttle program, and it has moved all of the modules that the Space Shuttle moved up to the ISS. So the interior of that fixture is the exact same as the shuttle is. So we're going to be putting this in the plane and moving it to Florida in a week, and we have to move the plane 180 degrees out right now for the winds. Is he moving it? You're good? Go ahead. It's good. Okay. All right. Okay, I'll get the back. If you want to take a look at this, you can see how we connect the tow bar. So as I said yesterday, we actually carry our own tow bar. It's unique to this aircraft. And so we're going to connect that now. Okay, last piece of business before we can move this is we've got to bring up this strut in the back. So sometimes we'll leave this strut down for winds and whatnot, so it just helps the aircraft during high wind events, and that's what we did this weekend. All right, let's see here. Ooh, I'll kill myself. So, first thing we've got to do is lower this locking nut. So in case the hydraulic fails, we have this locking nut raised up to the top so it won't collapse. That has never happened, but it's a good backup for us. All right, now right there, make sure this is loose so it doesn't bind. Did you turn power off, Tommy?
Huh?
Did you turn power off? Oh, can you go make? Yeah, it needs to be on.
Don't worry about getting out of the shot. You're part of the crew, so just do your thing. That's what I'm filming. Is behind the scenes stuff.
Yeah, we gotta get power back on the aircraft.
Right.
Turn it off.
When I go like this, it's okay.
That's you.
Okay.
You're on camera. You're famous.
But thank you, though. I appreciate the courtesy, though. Thank you.
I don't even think I need to raise this all the way up. I'll probably just put it up.
That's what I was.
I'm just gonna put it up hydraulically, and I'll put it up hydraulically, and we'll leave it extended the rest of the
I'll
way.
raise it up to the last pinhole. That way it gives us more room.
Yeah, we can do that. Yeah, we can do that.
Just raise it up.
Just get up out of the way. Oh, there we go. We pull the pin. Go ahead and pull the pin. Hold on. Wait till it comes up first, Jack. Okay, go ahead.
That high now?
That's fine, yeah. As long as it's out of the way. And then we just pull that, put that up on the stairs. Is that good for you, Tommy? Is that good for you? I figure we'll just lift it up out of the way. Okay. I'll do brakes.
Sure.
Is that cool? Okay.
You just want it pointed that way.
Yeah, the winds are out of the southwest. I think you just turn it 180. I think that's fine. Okay.
The important part is that because
Yeah, I guess that's what Yeah, I was going with this one, sir.
Jack said just
Right, yeah.
Jack, where do you want it? On the line or angle? The line. Okay.
Oh, he wants it on the line.
Line? Okay. Yeah.
break off?
No, he never put brake.
Okay. Going back. Definitely need the loader here.
Yeah, the loader has to. There you go. Hold on, wait.
I'm gonna get the power part.
Yeah.
Is that good?
Yeah, let's start it there. We can just point it in that one.
Oh.
You already depressurized, Dave?
I did, yeah. Yeah, you can get the hydraulic and you can, and also the electric. So we'll get the hydraulic. Outrigger fairings are off. Yeah. Okay. So we depressurize the hydraulics from up in the flight station. After we turn the nose, which we've already done, we go ahead and depressurize the hydraulics, and so now we're going to disconnect these two large hydraulic lines, pressure and return here on the side. So that's what he's got doing, and then there's a gate valve that he's going to close right there, and so we are good. Hydraulic lines, and then can you get the, yeah, and then we've got these three big electrical cables, connections that come off, and an extension cord that goes up in their place. You'll see that in a second.
You want my autograph now or so I can go famous?
Nelson, why don't you go ahead and get the back? Want to get the back?
Yeah.
Yeah, so just run it from the top and, you know, yeah. All right, good. I'm gonna grab some ears.
Yeah.
I grab these.
that will arc.
Oh, yeah.
Okay, so our next action is going to be to put the struts down. We start with the back. Obviously, if we put the fronts down first, you know, it's possible that we could do a tail stand. So we put the tail down first. Tail always comes down first, it goes up last. So that's what Nelson is doing right now. So I've got the system selector into main. We're going to run the hydraulic pump is separate from our aircraft systems. We've got a separate hydraulic pump here. This runs all the ground hydraulics for the nose opening and with the separate reservoir up here, but that's completely independent of the aircraft systems. So we got it in main, and he's going to first we lower it down mechanically all the way that it'll go, and then he'll put some pressure on it hydraulically. It's good. I think you're good. Yeah. So you'll actually see the aircraft come up here in the back. We'll lift the tail about 6 inches or so. Putting 350 PSI in the back. That's the number that we're looking for on our gauge here. All right. And then the last step is to tighten that locking nut that we loosened up earlier. So we'll tighten that locking nut up in case the hydraulics were to fail. All right, now we're going to go do the front. Okay, let's see if I can get some help on this one. What's that? If I can get this thing up here.
Bring these up.
Huh? Yeah. Need some help? Got somebody over there?
Bring it down.
Yeah, grab me that top thing. Actually, let me get both of them for now, and I'll go help to. Just don't lift it up and down. Let me see if I can get my fingers in there. Okay. Get it laid all the way down, and I'll do it. Now this one's got a reverse thing again. Go. Ready? Stand closed. All right, here we go. Okay.
Hi, my name is James Getze. I'm the NASA Super Guppy Loadmaster, and right here we have the SGSF shipping fixture, and it's loaded on the CLT cargo load trailer. The cargo load trailer can carry 50,000 pounds, and let's go take a look at one of the controls that we have to do our fine adjustments when we get it up to the aircraft. So once we get it positioned to the aircraft, to do any fine adjustments, we have 4 struts that are located on the bottom of the load trailer, and we articulate those struts here with the Strutmaster control box, and that gives us our fine adjustment if we need to move left or right, because this is a very long piece of equipment and it needs to be lined up perfect, and we do that all with just a string and our eye. And in a little bit, we're going to be moving this whole contraption over in front of the Super Guppy, and we're going to be lining it up and loading it onto the aircraft for a flight a little bit later today. What we're doing now is the engineers are in the process of opening the main door, and the whole nose of the aircraft will swing open.
I think maybe a little more. Let's ask Jack. For Jack. Jack, come look. Make sure you're happy with it.
You got a little bit of a tip out?
Huh?
You got a little bit of a tip out?
No, I'm just. Do you want it more, or is that good for you?
That should be good.
Okay. All right, we're good. Yeah, you put that in. Huh?
It's gonna be that close.
Ooh.
Okay.
Cutting it close today. All right. I have not seen this thing. I don't know if I've ever seen this thing in here.
Probably only in pictures.
Yeah.
2008.
Yeah, I don't think I've ever. So we're not going to be able to see each other on the other side, and I bet we don't have our little mics.
They're in there, but they're not charged.
Charged.
I forgot about it.
You want to do whistles just in case?
They're probably on the tug. We're gonna need whistle.
Verify the winch connections. The winch does not have a tow bar on it right now. The tow bar is sitting right beside this. You see the tow bar?
Oh.
Fire? That's the tow bar we're using for the SKS.
Oh, it's different?
Yes.
Oh, okay. Was it longer or?
It's got 2 pins and it's a little bit longer.
Okay. I've never seen that before. All right.
Okay. Loadmaster 2 will be James. He's going to operate the loader, act as a safety monitor, position CLT, operate platform controls, ensure the installation, removal, and stabilizer structure stands, operate the stabilizer structure stands, ensure the stabilization removal of the left and right side safety pins. Take the last 2 out. Okay. All right.
Yeah.
Problem.
I'll leave the safety over on here.
If anybody sees anything, yell,
Blow the
scream.
whistle.
If somebody hears it, repeat it.
Yeah.
All right, so that we can hear the noise.
Yeah, so one long blast on the whistle, and if you got a whistle, repeat it so everybody in the back can see. Because again, they're driving it in, they can't see us. So,
If you hear the whistle, we stop.
yep, that's full stop. All right.
All right. Any questions? Dave, I'm assuming you're operating on.
I will operate the winch.
Okay.
So for ours, only one winch cable. We'll check the winch line, the winch mount, the cable, and all the rollers and pulleys on our way up. Tommy, you got locks. I got winch. We already know about the ground personnel safety observer. Make sure we get it in pallet before we go up. That's it. If for some reason the thing doesn't stop when we want it to, make sure you kill power up front. Charge up the brakes. Park brake set. All right, let's see. I don't think we need to lower the flaps today. All those are good. Weather radar, not so. Standby. This master, emergency horizon, radar altimeter. Yeah, good here. Feather buttons are all in neutral. Exterior lights. Let's get the nav lights on. Be good enough. Emergency flap switch down and guarded. All right, that's all up here. Let's see. So we got 4 tanks, 2 boost pumps in each tank, a front and rear boost pump, and each of those has a low hit setting and a high setting here. So looking for a minimum of 15 there and a minimum of 30, or typically quite a bit more than that. All right, and then we're just going to test out our fuel selector valves. So this allows us to select the fuel from tank to engine. If you just kind of follow, we call these the chicken feet, right? You follow the chicken feet, you can see it goes from the tank to the end to the number 1 engine. If we do it this way, now we can go tank to engine to manifold, and that's how we cross-feed fuel to the rest of the aircraft. So the thing about selecting these, so we've got this electrical switch here that's just running a motorized valve down in the flap well. This light here tells us whether this switch and that valve are synchronized. So every time we do this in flight, for instance, if we want to balance fuel and we're turning this, we're watching this switch here, this light here, to make sure that it actually does turn that and they match up, because if it doesn't, it'll starve the engine and shut it down. So we just run through these. And then I'm just going to go to tank to engine for engine starts. Go. All right, this here is our refuel valves. If that light's on, it means they're all closed. So all of our refuel valves for the tanks are closed. Got that. Let's see. Fire detection. This is what our fire detection sounds like. We could cut that out. So we got 4 lights up here to show us the different engine fire lights, and then you've got lights in the handle, if you see down below there, on the E handles, the emergency shutdown handles right there. And then there's 1 light up at the front, and so that tells us, gets our attention for sure. And then we got that bell. Okay, so those are good. And do a lights check real quick. Make sure all our lights up here, good. Lights here, good, and all on my panel. Got all the lights. All right, warning lights are checked. Okay. Check. All right, I got you. All right, we're gonna start all 4. So 2143. Standard stuff.
Can you hear me now?
Oh, Tommy, can you hear me? Hey, there you go, Tommy. How about now?
I can hear you.
Hey, you got to turn that switch. That's the right position.
There you go.
There you go.
Dave, you got me?
I got you. No. There. No. I turned it for you.
Oh,
you turned it back off. It's got to be up like that. There you go. Now it works. All right.
Hey, you started, John.
Yeah, you can hang out. Okay. All right.
Party.
So I've already run through this. I'm going to run through the before start checklist. Everybody ready? Parking brakes.
Good.
Shocks, covers, pins. Covers off. Pins are in. Forms and flips not required. Fuel quantity, we got lots. Water methanol. We have the inboard tanks still. Takeoff data, we're not doing that. Altimeters, doesn't matter. Hydraulic pressure selector and quantity. That's you. So Got 3 gauges in the green. All right. Let's see, warning lights, I've checked them. Check yours. Master fire warning. You want to check it again? Here you go. It works. It's good. Emergency depressurization switch, down and guarded. Power levers are at start. E-handles are normal. Temp datum switch, we got a malfunction on 1 right now, so I've got 2, 3, and 4 in normal. Oil cooler flaps, I'm up a little bit, but they are less than 100 for starts. So I'm just opening up my oil coolers. All right, that's good. RPM switches. Got them in low, okay. I'm gonna point to those real quick. Which one of those RPM switches are in low? All right, rotating beacon. Battery switch is in normal. Fuel panel, I've got tank to engine, and I've got 4 pumps are in low. Bleed air fuselage valves, I'm gonna go ahead and do a, I'll just isolate the, yeah, actually, sorry, I'm gonna do it, and do this one, yeah, and that one, that's right. Okay, we'll do an isolated start just on number 2, just to, for the air. I just faired them. Yeah, they're not open all the way. All right, so we're set for an isolated start on number 2 engine. Engine fuel and ignition switches. There's 1, 2, 3, 4, all on. All right, we're ready for external air. All right, Tommy, you got the clock, 60 seconds. All right. Okay. Yeah. There's the heifer. So we're not gonna, just so you know, we're not gonna get fuel flow on 1, but we'll get a light off and then we'll get a break for that. All right, waiting on air. So we're waiting on external air. There we go. So I have air. It looks like about 40 PSI right now. So we're ready. You guys ready for 2? All right, 2 is selected. 40 PSI. Button is in. Air drop. I've got rotation indicator. Waiting at 16%. Make sure I've got good air. I do. There's 30. Now look at fuel flow. I got light off. Oh, that's right. The breaker's out. We got light off. Oil pressure in 1. Oil pressure in 2. There's pumps in parallel. There's 50%, 827, button is out, air's back up, and there's low RPM. So I got 827, what's the time? Second, all right. Okay, good start. You can ship that one up. Sorry, 2. Yeah. Ship it up to. Good, RPM is stable, oil pressure looks good. Okay, generators. So until I turn this generator off, that fail light will be on, but we can have let's see. All right, that's good. Start on 2. Let's go ahead and select 1. Okay, and I've got about 185 PSI. 4 selected. You guys ready?
Yeah, we're going ahead. You're clear on number 4.
Okay. 4 selected, got 80 psi, and the button is in.
Rotation.
Airdrop. Rotation's indicated. Wheel pressure's on the rise in both sections. Fuel flow. There's light off. Got pumps in parallel. Through 50%, buttons out, 80, 816, all right, and there's low RPM.
28 seconds.
All right, normal start on 4. I don't think you need to shift it up unless you really want to.
You know what? Yeah.
Yeah, you don't need to. I don't think you can do that one. Okay, you ready for 3?
Yes, you are clear on 3. Go ahead.
All right, 3 selected, 80 psi, and the button's in.
Rotation.
Time.
Rotation's indicated. All right. Let's see, there's fuel flow. Light off. Got oil pressure on the rise, both sections. Pumps are in parallel. %, over 800. Buttons out, 823. There's up and lower RPM. All right, that is that.
30 seconds.
After start checklist, start selector is off. ECS ACMs are on. AC/DC generators are all basically on. There we go. All right, weather radar not required. DC heat not required. Engine ice not required. Ground equipment personnel's already been cleared off. Doors, equipment. That's it. After start checklist complete. All right, Tommy. So looks like your fuel flow gauges are working. What else did you need? You got the RPM gauge up there working?
RPM is working.
Okay. Shift down 1 and 2.
Down 1.
Okay.
Down 2.
All right. There we go. Sounds good. Eric, did you want a video of the engine shifting down?
Yeah.
Do you? All right, just shift 1 and 2 back up real quick. We'll show. I'll show you where to point. I'll show you where to look. Here, watch.
Oh.
So look right there. Look at those gauges. The bottom ones are %. So we're going to shift them up for you, so you can get a couple. You can get a little some footage. Go ahead. Shift
1
them up. Yeah.
1 up. 2 up.
All right. That's all stable. Okay. You go ahead and shift them. Go ahead and shift them back down.
1 down.
Yep.
2 down.
All right. All right, and then if you can start the clock for me.
Sure.
And that's that. Easy day. Oil pressures, temperatures are good. After landing checklist, the anti-skid should be off. It is. Flight controls are locked, water injection's off, sync system's off, flaps are up, weather radar is in standby, pitot heat is off, all the anti-ice is off, oil coolers are set, radar altimeter is off, lights are off, all that should be off. All right, we're going to shut down, parking brake is set, RPM's in low, EPIS master switch is off. Emergency horizons off, IRUs are off, TCAS off, DC heat is off, oil coolers are less than 100.
NTS feather valve switch is an NTS. Fuel boost pumps are coming off. Battery switch. All right, how are we at for time? Is that 2 minutes?
That's almost 2 minutes, about 2.
All right, so I'm going battery to emergency. And what do I have here? Battery emergency, CSACM's coming off.
2 minutes.
All right, field ignition switches. Here you go. Eric, you want to look at this? Here you go. Field ignition is off. All right, fuel selectors and work. Those are off. PD switches off. AC/DC generator panels, those are all off. Main inverter coming off. Radios, radio master switch.
All right, that one's off. Microphone again. Off, rudder's locked, red and yellow circuit breakers are out. Oxygen bottles, gear pins, and chocks. All right, we're good. That's it.